highlighted on platform and nicely paves the way towards the next speaker, who's Mr. HUA Xiansheng. He was the vice president of the Alibaba Group, and also we look forward to your speech. And I guess there's going to be a lot of food for thoughts in the end to discuss.
Okay,
please,
thanks.
Yeah.
Can you see my screen in play mode?
Yes, we can.
Okay, great. This is Xiansheng Hua from Alibaba Damo Academy. It's my pleasure to have this opportunity to share you some of our artificial intelligence work in the area of healthcare. In particular, due to time limit, I only introduced the techniques that we developed and applied in the epidemic caused by COVID-19. Hope this can provide us some inspirations on the areas and the modes that we may cooperate. I should be only need 10 minutes. There are indeed quite a few new technologies that are being used for combating COVID-19, but we didn't have. Here are some examples that I'd like to share today. The first one is CT image analysis solutions, which is a fast and accurate as well as a convenient way to diagnose COVID-19 infection. You know, when a new disease starts to spread, fast and accurate testing is very important. Typically, we need some time to get this test kit ready, especially for a high throughput solution. While if we use a CT scan images to diagnose the disease, we only need an algorithms or service to recognize the new thing, because we already have CT machines, we already have CT scan images for the suspicious cases. So the technology here is to use the latest visual artificial intelligence technology, as shown in this short video clip, to automatically determine whether the case is a COVID-19 infection or a common infection by other type of viruses or germs. Typically, it is very fast and accurate. The number we have in China is the accuracy can be as high as 99%. And we have analyzed over 800,000 people in total in more than 600 hospitals in China. In the middle part of the slides, we show the whole process of this solution, which is quite simple. And the right side shows the free cloud-based CT image analysis service offered by Alibaba. The second one I want to share is the whole genome sequence analysis based on distributed computing technology. You know, the most commonly used testing approach is PCR test, and the false negative rate is still high as it only checks 2 or more positions in the gene sequence. Whole genome analysis instead will do a full comparison between the test sample and the known genes of the virus. It is indeed computationally intensive and time consuming, but we are comparing, because we are comparing two very long sequences to find the matched segments. By using distributed computing technology and optimized comparison algorithms, we can shorten the comparison time from 2 to 3 hours to 10 minutes, which makes the whole test can complete in 14 hours. It seems still a long time, but already much shorter than existing approaches, which typically takes 2 to 3 days. One unique part of whole genome analysis for diagnosing COVID-19 is that the accuracy is almost 100% correct. And it is tolerant to errors during sampling or sequencing or gene mutations. Using the same technology, we can analyze the structure of a protein. And this helps accelerate the development of drugs and vaccines. These two technologies are all about testing. The third example is epidemic prediction, which is based on big data technology. This solution is not to cure the infection directly, but to provide data to policymakers and the medical institutions to make informed decisions and take appropriate actions, such as keeping social distance, putting on masks, travel advisories in time to contain the spread of the virus. As other epidemic, COVID-19 spreading trends can be characterized by mathematical models, as long as we know some key parameters such as infection rate, recovery rate, incubation rate. Based on publicly available data, such as the ones we listed here, we can estimate epidemic size, peak time, lasting days, and so on. The system also offers different predictions based on major events or policy changes provided by the country or region. For example, how strict the social distance restriction is executed. And based on our practice in China, the epidemic prediction service is able to achieve 98% accuracy with only 2-day lead time for generating the prediction report. And it offers more than 60 days forecast of the epidemic trends. The fourth example is about the communication and knowledge sharing based on natural language processing technology and speech technology. One thing we did is question answering. That means the general public can submit their questions to the robot using text or speech, which can be an app or can be an intelligent speaker. And then the robot will reply automatically with relevant answers to the questions. The other thing we tried is automated translation, which enables people to communicate efficiently almost in real time, even they are speaking different languages. Language and languages sometimes can be very difficult. Knowledge and experience sharing is one of the best prescription to combating the virus. The next one is cloud computing. It does not directly help retain the virus spread, but it is the platform to enable fast development, fast deployment, and scalable services for a variety of technologies to curb the spread. This is also why we are able to deliver the CT image analysis service in 2 to 3 days, and to make it serve more than 600 hospitals in a few weeks. Okay, these are the exemplar technologies that people were using to combating the epidemic, which we didn't have in the past. Technology at that time were not ready. Now let me share you some learnings. During this special time, rapid innovation is super important. The first thing we learned is that we'd better start to prepare for emergencies when we are still okay. That is repairing the roof on sunny days. So based on our existing technology we have been working on for quite a long time, we were able to create the new versions for combating COVID-19 very soon, including the ones we introduced. The second important thing we learned is that we need to move in parallel. From the first day, we need to take multiple things into consideration simultaneously. Data collection, model definition, parameter modeling, parameter learning, verification, engineering part, deployment, user interface and computation resource, and third-party dependencies, etc. We couldn't afford to run it sequentially because of the time limit. The earlier we can work out a solution, the more lives we may save. The third point is using latest technology. Let me give you one example. In the epidemic prediction solution, which is very difficult, besides using conventional models for the parameters, this is the most challenging part of the model, how to estimate those parameters. We also tried to use deep learning to estimate those parameters, which actually generate very promising result. Our prediction accuracy is as high as 98% in China. The last but not the least, we should know the most important thing during this time is to help curb the virus spread and to save lives instead of commercial considerations, for example, the cost and the return.
Brilliant.